Hi everyone. So my name is Mahdi. I want to present our work from unstable to playable, stabilizing Angry Birds levels via object segmentation. But in this work, I was not alone. So I want to mention my co-authors, Parsa, Rahmati, and Richard Zhao that are here in this room as well. Okay. So quick introduction. So as all of you might know, we use procedural content generation algorithms to create game levels for games. But ensuring the stability and quality of these levels might be challenging, especially when we don't have enough constraints on those, and like we don't want to limit our creativity. For example, this image here is an image of a defected Mario level, and the solution for this, like there are a few solutions. The first one is you might end up training a better model for this. You just need to fine tune your model. The other thing is you might end up using other models, but sometimes you don't want to just kind of like throw out the level that you just generated. So our solution for this was using repairer models, and instead of just trying to generate a new level, we tried to just repair the levels that we already had. There are a few works that have done the similar thing. So this is the work from 2020 that did the same work but with Angry Birds levels. But the problem was there were a lot of works about the 2D games, but they weren't like many works about the 2D games that have physics rules in them. So we tried to train a repair model for unstable AI-generated levels, and to test our method, we used the GAN-generated levels from Abraham and Stephenson works. They worked on Science Birds, which is kind of like Angry Birds, but for research. And the way that our model works is that it tries to find out the gaps in the level, and then it kind of uses the mask to find out about those gaps, and after that tries to fill those gaps with the material that we gave it to. This is the pipeline of our model. It first starts with, so we first gave it an AI-generated level. After that, we simulate the level in the game based on our own evaluation metrics to see if the level is stable or not. If the level is not stable, we use our model to feed the image, first encode XML to image, and after that feed the image to our repair model. The model tries to basically find the gap in the level, and then it tries to fill the gap with our default material. Here, default material was wood. If the model is able to find any gaps and if it was able to fix it, then the repair was successful. If not, we just consider it as a failed repair. So this is an example of our model. The first image on the left is basically a level that is generated using GAN, and it is unstable. And after a few seconds, it will just collapse. But when we use our repair model on it, the model was able to successfully find the gaps in the level and tries to kind of like fill those gaps. After that, we just use the decoder to decode from the image to the XML. And for just evaluating our model, we have three different metrics. 2 of these metrics are the same exact metrics that were in the paper, that are block destroyed and block velocity. Block destroyed is basically how many blocks are being destroyed after we load the level, and the block velocity is, well, if the levels are stable or if they are moving after we load the level. And the first one that we introduced ourselves was block damage. So if the blocks they are damaged on the blocks, and we just measure the total damage for the blocks. Just to make it short, when we did an average on them, our system nearly doubled the number of stable levels of GAN-generated Angry Birds from the original work. And while we tested this on Angry Birds, the core concept of our repair agent operating on 2D images and image inputs can be adapted to other physics-based games and even the games that are not physics-based. But testing the generalizability of this approach is the next step, and this is the thing that we should work on it. And I want to thank the NZERC for funding this project. And if you have any question, and if you are interested in this project, please come and see us tomorrow on the poster session. Thank you.